Hello everyone, my name is Eduardo. I'm a Senior Partner Solutions Architect with AWS, and today I have here with me Vijay from IBM. Hello Vijay.
Hi Eduardo, my name is Vijay. I'm the data platform sales lead at IBM.
So Vijay, I wanted to talk to you today about a common pattern that we see our customers discussing with us at AWS is they have IBM DataStage running, customers that have been using DataStage for a long time, and they're looking at ways to adopt DataStage on AWS and to modernize their DataStage workloads. We know that these customers are looking to bring their data to the cloud so that they can build generative AI applications, they can infuse their corporate data into all sorts of different workloads, right? So what can you tell us about DataStage and what are some of the options that customers have on AWS?
Absolutely. IBM DataStage is the product that does extract, transform, load, as well as extract, load, and transform for your data sets. And it does it in a batch mode. We'll talk more about different options that we have in terms of processing these data pipelines with some other patterns.
I understand that DataStage also has now a new offering from IBM, which allows customers to deploy certain components of it closer to where their data is sitting, right? Can you tell us a little bit of this new offer and how this helps customers modernize?
Yes, absolutely. So we have had this data stage product for a long time in the marketplace, which is our legacy product. But what we have done recently is we have modernized this data stage product and we are offering it for our clients on AWS. And we are calling this the Cloud Pack for Data Stage Anywhere solution. So,
Okay.
and it is available both as software as well as a SaaS solution on AWS.
Now, if we zoom in a little bit into the software solution, we can see that callback for data and data stage anywhere get deployed on a Red Hat OpenShift service on AWS cluster, or you can also use OCP, right, OpenShift Container Platform to deploy the product on AWS. If we look at this pattern here for ROSA, right, we are looking at the 3 availability zones cluster deployment because we want callback for data to be highly available, fault tolerant, and we want to make use of all availability zones that we can. So in this example, this is a ROSA classic cluster, right? What that means is that the control plane nodes and the infrastructure nodes are sitting on the customer VPC. Now, ROSA has other options like the hosted control plane deployment option, where customers only get the compute nodes deployed on their Amazon VPC. However, not all the services on Callback for Data yet support hosted control plane, so it's important for customers to always look for new updates to the IBM product documentation to understand what options they have available for deployment. And we also see that this is a public cluster. This is just an example, right? Customers also can use private clusters with AWS Private Link. For these types of workloads, we usually see customers that they just want to expose the workloads to their enterprise network, not to the public internet, right? And we also see the different storage options that Cloudpack for Data supports on AWS, right? Which is block storage through Amazon EBS or network file shares through Amazon EFS or Amazon FSx for NetApp ONTAP, where your data is automatically replicated across the 3 availability zones. But I also understand that it also supports IBM Fusion.
Yes, so what we support with many of our cloud pack platforms or software solutions is something called IBM Storage Fusion. That helps us, that helps customers to have a storage layer to store their data anywhere on a cloud or on a hybrid cloud environment.
Now, if we look at the ROSA deployment for DataStage Anywhere, with callback for data, with DataStage Anywhere, I think you have 2 main components, right? Can you tell us a little bit of what actually gets deployed from DataStage Anywhere into ROSA?
So a data stage anywhere has 2 components. We call it the control plane and the data plane. The control plane is the canvas, which is kind of drag and drop visual interface that you use to design the different stages of the workflow of the data stage job, right? And that's the component that gets installed on Cloud Pack for Data, ROSA. Okay. And then the other component is the remote engine where the actual transformation of the job is happening. And that can be deployed across multiple clusters, whether it's an EKS cluster or
vanilla Kubernetes cluster.
Or vanilla Kubernetes cluster, and The reason why we call it anywhere is because of this capability of running the data stage remote engine closer to the data where data is residing, right? That gives us the performance, the scalability, as well as the low latency to perform these jobs at a very fast scale.
So if we're looking here at this diagram, we have an example here of the remote engine running on Amazon EKS. So say if a customer has the data that they want to run the ETL or ELT jobs already on AWS, then it makes sense for them to use EKS to deploy the remote engines because that's going to be closer to their data, right?
Absolutely.
And what we see here is also that we have a 3 availability zones because we want to have high availability and fault tolerance for these jobs. Now, on this example, we see a worker node per AZ, but you could actually scale that depending on the number of jobs and the volume of data that you need to run the ETL jobs, right?
Absolutely. You can have a one node remote engine, or you can have a two worker node remote engine on an availability zone, and maybe a two or a three worker node on another availability
So
zone.
you can take advantage of the scalability of AWS and really elastically scale your workloads per your business requirements, right, and your application requirements. Now we also see that the remote nodes also has requirements in terms of persistent volume claims, right? So we see the different storage options that are available here, such as Amazon EBS, Amazon EFS, or FSX for NetApp ONTAP. Now, what we see on this pattern is using Amazon EKS, but the similar deployment could be done using Amazon EKS anywhere on-prem, right?
Yes.
So customers can run EKS anywhere on-prem and deploy the remote engine to stay closer to their data repositories, right?
Absolutely, yes.
Now let's take a look of how this ETL or ELT flow looks like from an end-to-end perspective. So what I see here is that we have different data repositories on the cloud, on AWS or on-prem, and we have our Amazon EKS cluster with the remote engine, and we have EKS anywhere on-prem, also running the remote engine. And as you talked about, we have the canvas sitting on ROSA. We do see some different components here. Can you tell us a little bit of how IBM stream sets and data band come into the picture?
Yeah, absolutely. So what you're seeing here on the left side with the three boxes is the IBM's entire product family under the data integration product sets. As we know, DataStage is very powerful engine to do ELT, ETL kind of workloads for batch data sets, but we are augmenting that capability with bringing IBM stream sets into the mix, which is really focused on real-time streaming data. Think about IoT sensor data or medical devices. All of that streaming data can now be transformed using stream sets.
Okay.
The other component that we see under the IBM Cloud Pak for Data is called IBM Data Replication. IBM Data Replication helps customers provide that high availability of data that are mission critical to clients. So we can replicate it in a heterogeneous or a homogeneous environment, both from source to target. The third thing that we see here is basically the data band, which is monitoring and observability tool across different ETL pipelines, whether it's a stream set pipeline or a data stage pipeline. It can also monitor airflow and some of the other third-party workflows as well.
So as you increase the complexity and the number of your pipelines, it's important to have an observability solution to keep track of what's going on, but also to remediate or resolve issues, right?
Absolutely. So what happens is, we are seeing that many customers, when you grow and scale up to like 2,000, 3,000 jobs, even 10,000 jobs, it becomes a nightmare to manage and monitor all these different pipelines. And that's where DataBand can really come in and figure out, if a problem happens, we can quickly fix or figure out where the problem is. And that helps us with bringing the mean time to resolution for a pipeline issue.
We look then at this architecture here, right? As you said, we create the jobs on the canvas that's sitting on ROSA. Now we see here that that's going to trigger the remote engines. Can you explain how the dynamics work? Like, well, from creating the jobs on canvas, how is it that the remote engines actually run those jobs? What's happening there?
So once we have designed the workflow on our canvas, there is a mechanism by which you can run the job. Now, when we run the job, it's basically triggering based on the different stages of the workflow itself. It will trigger the appropriate remote engine to do its job, whether it's picking it up from source system, doing whatever transformation it needs to do. It will then use the commands to deposit the transform data into maybe a warehouse, or whether it is any other data repository. It will do the actual transformation and moving of the data.
So we see here, like you said, this is DataStage anywhere. So the data can be sitting anywhere, right? We have some Amazon data repositories, and we have on-prem data repositories. We have IBM data repositories that are available on AWS through SaaS offerings like Netezza, DB2 Warehouse. Can you tell us a little bit about how many different connectors are available on DataStage anywhere?
We have a lot of data connectors, upwards of, I would say, hundreds of connectors. And these are all traditional data source data connectors to Oracle, MongoDB, the traditional, data stores. But what we have done is we have also introduced the new table formats, the open source table formats such as Apache Iceberg table formats. We can also work with Databricks Delta Lake table formats to read and write from these data sources into S3 using an S3 connector, or into an HDFS cluster using HDFS connector.
If we take a look at how these products are available on AWS, they're all available through the marketplace, right?
Absolutely, yes.
So if customers go through the AWS marketplace, they can find IBM Callback for Data or IBM DataStage for IBM Callback for Data. Those are available for purchase through the marketplace, and customers can also deploy those products from the marketplace on their Amazon VPC using ROSA. And with IBM StreamSets and Databand, those are available as SaaS, right? So
Yes.
What does that mean for customers?
So that means that it's a fully managed SaaS service. You don't have the headache of deploying this. It's available for you to use. You just pay for the service, and you can start using the service without the headache of managing and deploying it.
All right. Thank you, Vijay.
Thank you.
Thank you all. See you next time.
Thank you.